Hello, my dear students. I'm back with a new video. Today, we're going to talk about something very important, that is energy and types of energy part 2. Already, the part 1 video is already posted, which comprises of potential energy and the kinetic energy. Right? So, today we are doing part 2, that is energy and types of energy part 2. So let us learn about the various kinds of energies in detail, everyone here. So we'll be talking about light energy, chemical energy, we'll be talking about the thermal energy, nuclear energy, electromagnetic energy, sound energy, and many other types of energy. So let's talk about the various types of energies here. Right, so let's see what is energy. As we last time also we talked about, the ability to do work is called energy. Any capacity, okay, to do a work, ability to do a work is called energy. And types of energy will be dealing with chemical energy, mechanical energy, elastic potential energy, magnetic energy, electrical energy, sound energy, electromagnetic energy, nuclear energy, and thermal energy. So thermal energy, internal energy, heat energy, all are same. So we'll be dealing with all these energies, everybody. Right, so let's begin with the first type of energy, which is called mechanical energy. Mechanical energy is also the total amount of kinetic and potential energy in a system. So basically it comprises of kinetic energy and potential energy both. Winding up toys, grandfather's clock, and pogo sticks are the example of mechanical energy. Here wind power uses mechanical energy to help create electricity. Basically all the machines which are there, they possess mechanical energy. So simply you want to detect where the mechanical energy is there. If you see any machine working, means the mechanical energy is surely there. So potential energy plus kinetic energy is called as mechanical energy. So easy to remember. Any machine is working is mechanical energy. A fan is moving, mechanical energy. Turbine is rotating, mechanical energy. Okay, so any rotor is moving, mechanical energy. Any machine is working, it will comprise of mechanical energy. What is chemical energy? Chemical energy that is available for release from the chemical reactions. The chemical bonds in a matchstick store energy that is transformed into thermal and electromagnetic energy when the matchstick is struck. Cell consists of chemical energy, coal consists of chemical energy. All these weapons, bomb weapons, they consist of chemical energy. This cotton candy itself is a chemical energy. It's a chemical which is consist of your food is a chemical energy. Of course, all the plant trees, they have the chemical energy in them. That's in the form of cellulose. Right. Moving on next type of energy, that is elastic potential energy. Very important. Right. What is elastic potential energy? Elastic potential energy is the potential energy stored as a result of deformation of elastic objects such as stretching of spring. It is equal to the work done to stretch the spring, which depends upon the spring constant K as well as the distance stretched. So look at this here. This is a normal spring when you stretch it. So this is the distance which is stretched, and of course there is a elastic constant which is called as K is involved in this. Similarly, here you have a bow and arrow. Nowadays Ramayana is on, so bow and arrow is there. When you stretch this bow, obviously that distance is there which we take, and with the help of K we evaluate this elastic potential energy. According to the Hooke's law, the force required to stretch the spring will be directly proportional to the amount of stretch. This, if you apply more force onto this thread, it will be more stretched. Means force is directly proportional to x. X means the stretch which is happening, the elongation which is happening. Similarly here, if you are applying more force, more elongation will happen. If you apply less force, less elongation will happen. So that is why you say Hooke's law says that force and this distance, elongation, stretch is directly proportional to each other. So we got equation F is equals to Kx. That is the Hooke's law. The elastic potential energy is given by formula half kx square. Today I'm not discussing about how we got half kx square. For that I have to make a new video. Just today remember that elastic potential energy is given by formula half into kx square. Okay, k is called as spring constant and x is the distance that is stretched. So elastic potential energy is given by formula half kx square, where k is called as spring constant, x is called as stretched part of the spring or the elastic body, right? So all these are nothing but examples of elastic potential energy, right? Magnetic energy. You can see a bar magnet, and you can see iron filings showing the magnetic field around it. You can see two magnets having the same poles, so you can see that they are repelling each other, and you can see the various magnets with the different polarities here. So what is magnetic energy, by the way? Some objects can be magnetized and create magnetic fields. They can exert forces on each other or on magnetic materials, and this force which is exerted by one magnetized object to the other or the other magnetic material is called as magnetic energy. The magnetic field created by bar magnet is shown here using iron filings. You can see that a bar magnet and the iron filings are here, and they are showing the area around this magnet, and this is nothing but called as magnetic field. Also, we need to know that like poles repel each other. Okay, so here are the like poles, which they repel each other, whereas unlike poles attract each other. So you can see north and north, and they are repelling each other. Whereas if you see unlike poles in north south, they are attracting each other. So like pole repel and unlike pole attract each other. Now going on to the very important property here, repulsion is the surest test of a magnet. We can identify that a given substance is a magnet or no. That property is only called as the repulsion. So if a given substance is repelling a magnet which is given to you, so we can surely tell that the substance which is given to you is a magnet. So repulsion is the surest test for a magnet. So repulsion is the surest test. This is what we're going to prove. All right. To prove that, I need to have this. I have this uh, piece of chest piece. Okay. For that, I have a safety pin and one normal pin I have. Okay. Now what do I do is I take this magnetic piece. Okay, that is chest piece close to this. So you can see that this is getting attracted. Now when this is getting attracted, I bring it close to this one, and I find that this pin is also getting attracted. So when I bring it close to this one, I can see that that pin is also getting attracted to it. But I'm sure that key here is, if I remove this, so it is gone. It is now when I bring it close to this, when you saw that it was attracting this piece, but I'm sure this is not a magnet, so attraction cannot be the surest property. You cannot say that just because it was attracting this one, so this is a magnet. It cannot be. So what could be the surest test then? So surest test could be possible is the repulsion. So for that, what do I do is I take another thing and I bring it close to it. Now when I bring it close, here what do I see? I see that it is repelling here. It's going, its repulsion is happening here. So when I bring it close, I can see that it's repelling. So this is the way we can say that the repulsion is the only surest property. So repulsion is the surest property. But here, if I have these pins and if I bring it close, you can see that it is only attracting and it's not repelling. But then same thing, if I bring it too close to this one, I can see that there is a repulsion happening. See, there's a repulsion happening, it's not attracting at all. But if I bring it to them, it's... So what does this conclude? It concludes that the surest property is what? Repulsion. Repulsion is the surest test for a magnet. What this picture is showing you, what these pictures are showing you exactly. So you can see there is lightning here. I can see there is cables going all the way from these poles, and you can see that here plug-in. Okay, I can see windmills. Okay, these are the lights which are on. So it's talking about the electricity basically. So we're talking about what is electrical energy. So electrical energy is caused by movement of electrons. What is electrical energy? It is caused by movement of electrons. And these electrons or these electricity or this electrical energy is transported through power lines and converted into other forms of light or sound or other forms of energies once it reaches to you. So this electrical energy is transported through lines, okay, that is the power lines, okay, big holes you need, and there are wires which are taking this from one place to another, and once it goes to your house it converts into various other forms of energies. Moving on, next is we're talking about sound energy. What is sound energy? Sound energy is caused by an object's vibration. To make an object vibrate, work must be done to change its position. Example, when you pluck and release a guitar strings, so it starts vibrating, starts moving, okay, and this vibration produces sound. When a guitar string moves back to its original position, it has kinetic energy because it has moved and come back, come back. So it has a kinetic energy, and this kinetic energy converts into sound energy. So basically, when anything vibrates, basically it has a kinetic energy, and this kinetic energy converts into sound energy. So you can see a person is uh, having a guitar, and the strings are vibrated and it produces sound, and then these are the other forms of these are the other instruments which produce sound energies. Moving on, next, electromagnetic energy, very important everybody. Electromagnetic energy is the one which travels in the form of electromagnetic wave. So what is electromagnetic energy? Electromagnetic energy is nothing but which is traveling in the form of electromagnetic wave. So they do not need a medium to travel. So these electromagnetic wave, these electromagnetic energies, they do not require any medium, solid, liquid or gas. They do not need. Even if there is no medium, there is vacuum, they can travel. So even light is a form of electromagnetic energy. So that is why I'm not covering that as a separate energy, but then light is also a form of electromagnetic energy. Of course, light has got certain properties which can be dealt separately, but then light is also a form of electromagnetic energy. Electromagnetic energy comes in many forms, including gamma rays, X-rays, ultraviolet radiations, visible light, microwaves, radio waves, infrared radiations. Here is how to identify them, rather how to remember that what are the forms. You can see here in this picture, all these are nothing but the forms of electromagnetic energies. Here you can see thermal imaging, you can see here microwave oven, you can see here mobile, you can see towers here, you can see everything here, you can see x-rays. So all these are nothing but the, you can see light, the different forms of energies. These different forms are nothing but electromagnetic energies. So how to remember this? So I'll tell you the short way or the short form to remember these is nothing but Army Vux G. What is that? Army Vux G. Now R stand for radio waves. Okay. M stand for microwaves. I stand for infrared. V stand for visible light. U stand for ultraviolet. X stand for X-rays, and G stand for gamma rays. So you can see that I'm taking short forms R, M, I, V, U, X, G. So in short, I read it as Army Vux G. You can easily remember all. Right? Moving on, next. Here is, if I show you these different forms of electromagnetic energies, if I group them in the form of wavelength and the frequency, you need to remember very important. What is that is, if you're going from Armivux G, that is from radio, if you're going to gamma. So if you're following that path, radio wave, then infra, and then visible, then UV and all that. If you're following that, so if you're going from right hand side in this picture I'm talking about, if you're going from right hand side to the left hand side, that is to gamma. So you will find that the frequency is increasing. So gamma has the highest frequency, whereas the radio has the least frequency. But frequency and there is something called as wavelength, they are inversely proportional to each other. So if you find that the radio has the least frequency, so since it is inversely proportional, so obviously it will have the longest wavelength. Okay, so radio has the least frequency, but it has strongest wavelength, whereas the gamma has the most frequency, or you can say the uh, more frequency, but it will have the least wavelength. So that's very important. So even if you remember one, the other one you will remember, because that is exactly opposite. So frequencies are increasing when you're going from radio to gamma, and whereas the wavelength is decreasing when you're coming from gamma to radio. So radio is more having more wavelength, whereas gamma is having least wavelength. Right. Moving on next, everybody, we're talking about thermal energy, which is also called as heat energy, which is also called as internal energy. So here we're talking about what is heat energy. The heat energy of an object determines how active its atoms are. So if you touch a hot object, okay, if you touch an object which feels you hot, means that whose atoms and molecules are excited and show rapid movement. So hot objects are the one whose atoms and molecules are excited and show rapid movement. Whereas when you touch something and you find it cold, so cooler objects, molecules and the atoms will show you less movement. So less movement cold, whereas the rapid movement is hot. So here the internal motion of an atom is called heat energy, and because moving particles produces heat. Even there is a friction also produces heat. Okay. So heat energy causes change in temperature and the phase of any form of matter. So that's very important part. Moving on to next is nuclear energy. What is nuclear energy is all about, everybody? Energy stored in the nucleus of an atom released by fission or fusion is called as nuclear energy. So here is energy from the sun, which we receive as nothing but it's a nuclear energy. Stars, nuclear power plants, energy stored in center of an atom. Even fission process, okay, like how we have a fusion and fission. Okay, fission means breaking apart, whereas fusion means forming. Okay, it is combining. So let us talk about them in detail. So when I'm talking about the fusion, it takes place on the sun. Sun is the most powerful source of energy. The nucleus of an atom is the source of nuclear energy. So let us do nuclear fission and fusion separately. So I'm taking first nuclear fission. Let's talk about it. What is nuclear fission is all about? Nuclear fission is a process in nuclear physics in which the nucleus of an atom splits, remember, fission means splits into two or more smaller nuclei as fission products, and usually some byproducts particles. Hence fission is a form of elemental transmutation. What do you mean by this? It means that you have one nuclei, let's say I have uranium here, and whose mass number is 235 and the atomic number is the 92, and this is bombarded by slow moving neutron. So once you bombarded by slow moving neutrons, what happens is this nucleus, which is out there, the uranium, gets divided into krypton and barium. So krypton, you get the atomic mass is 92 and number is 36, whereas barium you get the atomic mass is 141 and the atomic number is 56. I need to know that 92 plus 141 is equals to 233. Means I had a nucleus of 235, but then here the receiving two nuclei are the two lighter nuclei than this are 92 and 141, and if I add them I get 233. Means where is the loss of 2? Gone. So this loss which you can see here is gone. Rather, it's not gone anywhere, it has got converted into energy. So along with this barium and krypton, you get a tremendous amount of energy, which is equal to when you burn tons of coal, you get the energy, that much energy you receive during one fission reaction. Now, along with this barium, krypton and tons of energy, you get three neutrons also. Suppose these three neutrons are again bombarded, or they are bombarding uranium nuclei. Again, you get barium and krypton and tons of energy. Again, three neutrons. In each case, you are getting barium, krypton, and tremendous amount of energy, and the same thing. And if it is again bombarded by if these neutrons are bombarding nucleus of uranium, Again this process continues and it's become a chain reaction. So here from 1 I got barium and krypton, 3 neutrons. Now these 3 neutrons are reacting with uranium again, and again you are getting barium krypton in each, and of course tremendous amount of energy in each. Again those 3 neutrons are bombarded to uranium, again you get the same process and you get a chain reaction. Now every time, imagine if you're getting this kind of reaction happening, it is very fatal. And if this reaction is not controlled, it's become uncontrolled chain reaction, and which is actually happens in nuclear bomb. So when nuclear bomb is released, basically uncontrolled chain reaction happens, and that is why it destroys a larger area. Whereas this can be controlled also. This reaction can be controlled in laboratories, and which we do it, rather all developed countries which are there, they're using this technique to produce electricity. So they control this reaction by means of cadmium steel rods. Okay, so when they do that, they inhibit this part and they don't let this reaction to go further and become a chain reaction. Uncontrolled, they become, rather it's controlled by them, and hence that heat which is produced here will be utilized to produce electricity. Moving on next, now this was a nuclear fission, right? We are talking about the nuclear fusion now, right? Need to understand. Nuclear fusion is a process in which one atomic nuclei, that is two nuclei are fused together into a larger single nucleus. In fission, one was split into two. Here, two nuclei are fused together into a larger single nucleus. So two are fusing together, two are combining together to make a one. Okay, also releasing tremendous amount of energy in this process. So basically it is the 4 hydrogen atoms are fused into a single helium 4 atom, releasing a lot of energy in this process. Let us understand what is this all about. Alright, so you can see that I have got the 2 hydrogen atoms. Actually these combine, this is a combination of 4 hydrogen atoms. So but then here is, I'm calling it as deuterium, and this is tritium. So deuterium, this is atomic mass is 2, and here tritium atomic mass is 4. Of course the hydrogen's atomic number is 1 only. So 2 plus 3, and that is 5, right? So if they are combining, I'm supposed to get a product which is helium. Here I'm getting it, but then look at this, 2 plus 3 should be 5, but then it is not 5, it is 4. Helium has mass number as 4. So where is the 1 ka difference gone? So it has not gone anywhere. That difference has got created into energy. So the difference which you talking about, that mass difference, is converted into 3.5 million electron volt. Again, I'm talking about the tons of coal. When you burn, you get this energy. And this process is continuously happening on sun. That is why we say that the sun is a tremendous source of heat energy. So this process continuously happening. Every second it is happening, right? So that's a nuclear fusion. So nuclear fusion is two or more nuclei are combining to form one, and along with that tremendous amount of energy is released, right? So we are moving on now. Next is quiz time here. Okay, let's understand. I think you will be able, now I'm not answering these questions here, I leave it to you. If you're not knowing the answer, please let me know in the comment box. Okay, what type of energy cooks food in the microwave oven? So you can answer that question. Here is what type of energy is the spinning plate inside the microwave oven has? Remember, so these two different questions, you have to answer them. Next question which you're supposed to answer is this one. Electrical energy is transported to your house through a power lines. When you plug an electric fan to a power outlet, electrical energy is transformed into which type of energy? So when you plug in, electrical energy transform into what type of energy? Here is next question. What energy transformation occurs when electric lamp is turned on? So you need to answer that. These I'm leaving it to you. So electrical energy converts into which form of energy? Okay, what types of energies are shown below here? So a man is pushing this carton, or you can say a box. Okay, what energies are involved in this? So when he's pushing, obviously you can say muscular energy, and when it is moving, you can call it as what energy? Yeah, kinetic energy. So muscular and kinetic energy. What type of energy is shown below? That's a chemical energy, as I told you. Right, what type of energy are shown below? So basically you can see here it's a remote control. Okay, and when you use that, infrared radiations goes and you can see light energy on a TV. So you can call it as infrared, that is electromagnetic energy, and the light energy is also there. So obviously electromagnetic energy, infrared, which is there in the remote, and from the TV light energy is coming. So electromagnetic energies. What type of energy shown below here? It's a tomato. So it's a chemical. So it's a chemical energy. Okay, so with this we come to an end of this video. Thank you for watching this video, and don't forget to subscribe and share this video. Thank you so much. Meet you next time in another video.